I found myself wishing recently for a dedicated oil spreading device for my cast iron pan, accompanied by an annoyance by inconsistent oil application. I set out to create a stylish tool to accomplish both simultaneously: a device that can evenly spread oil and dispense it at the will of the user. Comprised of a wood handle, aluminum bottom, woven butcher's twine, and plastic oil reservoir, this device packs functionality compactly and elegantly. Starting with the fur stalk, cut to length, a hole large enough to fit the reservoir was drilled using a Forstner bit. Small side cutouts were also drilled for the plastic extrusions, with a saw fed through the holes to remove the excess material. A surface profile template was created to trace the intended projection geometry, which was subsequently bandsawed to remove as much material as possible before sanding. Curvature was achieved using the belt and rotary sanders, with careful attention placed on the lower 2-inch radius where the aluminum bottom would encapsulate the wood. The part was returned to the rotary sander until the entire lower section of the handle was roughly 2 inches. Next, a Dremel tool was used for cleaning the remaining wood on the side cuts. Starting with a rough 120 grit sanding and proceeding to a 240 grit sanding prepared the handle for staining, which was a single coat of dark mahogany followed by a polyurethane coat 8 hours later. Proceeding to the aluminum bottom, this part was designed to be highly compatible with the lathe and only required external radius downsizing and internal radius boring. A small channel was created toward the end of the part, the purpose of which will be demonstrated later. After parting, the bottom was reversed and filed down to achieve some curvature. It was then placed onto the mill where the 3 fastener holes were drilled and the center channel chamfered. Fastening the aluminum bottom to the wood handle, butcher's twine was threaded around the small channel mentioned earlier. This piece of twine contained 7 individual loops, through which a long, continuous length of twine was threaded. This built up the bottom surface of the aluminum bottom, creating the primary cooking oil applicator. Once built up, more twine was tightly wound around the side of the aluminum bottom to completely cover the metal. And finally, the plastic oil reservoir was thermoformed using a 3D printed template. PC, PETE, and ABS all failed to achieve the desired dimensionality and mechanical properties, and thus was a failure. To complete the build, 3D printed TBU was employed. The substitute was inserted into the wooden handle, and oil was fed into the reservoir using a retrofitted straw and valve. Unfortunately, this rapid prototype was found not to be airtight and could not secrete cooking oil as intended. The next iteration will include a silicone molded plastic insert, a method of manufacturing that should be vastly more effective than thermoforming for this application. Overall, the product is very effective at spreading oil and only needs minor refinements to become fully functional.